Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Your host is Tobias Macy, and today I'm interviewing Tammer Saleh about the potentials and pitfalls of using Kubernetes for your machine learning workloads. So, Tammer, can you start by introducing yourself?
Oh, absolutely. Thank you, Tobias. So my name is Tammer. I founded SuperOrbital back in 2017. We are a engineering services and training company focused on solving extremely difficult problems using cloud native technologies. And what that means is just, we do the hard things on Kubernetes. Before that, I was part of Pivotal Cloud Foundry and went back and forth between software engineering and operations. So I kind of have that DevOps mindset just because of my history.
And do you remember how you first got started working in that cloud and Kubernetes ecosystem, and maybe a bit of your exposure to and background in machine learning as well?
Yeah, absolutely. So like the cloud ecosystem was kind of interesting because I'm old, right? I started off when Linux administration meant driving down to the server room and racking and stacking machines and installing everything from hand. I'm sure you remember, right?
Yep.
And yeah, I swear every time I went to the server room, I would come back bleeding. I hated it so much. I carried Band-Aids with me because those VA Linux boxes were terrible. And I remember back in the day, the cloud was it was literally the thing you drew on the whiteboard, right? It was the thing to represent the rest of the internet, right? And when cloud computing became a thing, that's when I was working for another startup. It was called Engine Yard. And it was basically the worst interpretation of cloud computing you could imagine. It was just like we resold AWS machines with a little bit of configuration on them and a lot of white glove service. That was our superpower. But then Heroku came around. Do you remember Heroku? Did you ever use it?
I actually still use it today for my work.
Well, that's fantastic.
And yes, I've been using Heroku for many years now, off and on, so I'm altogether too familiar with it.
Well, the interesting thing is Heroku was even more ambitious when it first came out. Do you remember it had that cloud IDE that was an integral part of Heroku that later they decommissioned, right?
I think I came to it right after that, but I have heard many recountings of that history.
Yeah. And it looked like a toy. We made fun of it. We're like, well, nobody's going to post anything on that. We don't even, how do you even SSH into that? How do you back it up? How do you do any of the stuff that you're supposed to do? But that was the groundbreaking transitional moment when people really started thinking about what the cloud and what a platform would mean, right? And to be very frank with you, saying this as somebody who runs a company based on Kubernetes technology, I still feel that the industry took a step backwards from that 12-factor model. I think it needed to. The whole 12-factor thing was a little bit presumptuous, a little bit egotistical. We tell you how you should build applications. But it was very natural for me when I embraced it, because at the end of the day, 12-factor, the whole Heroku Cloud Foundry model was really just write a good Unixy process and we'll take care of it. You stay within the bounds of like DJB DNS, like the old run it stuff. Like stay within the bounds of what it means to be a good Unix process, and we're good. So, anyways, because of that, like I kind of naturally transitioned into cloud and moved into Pivotal, ran engineering for Pivotal Cloud Foundry, and then formed SuperOrbital shortly after. With the ML workloads, it's really interesting. Now, first of all, I just want to say, like, I'm not a lawyer, right? I am not an ML engineer. That is not my trade. I wrote a couple of neural networks when I was in college. Like we've all tried neural nets in college, right? Like, I experimented, and that was basically it. But we are, myself and all the people here are obviously extreme experts in all things Kubernetes and beyond. And the reason that Kubernetes beat the whole 12-factor platform is because it came to you, right? It said, look, you don't have to adapt to our model of what compute should look like. We will embrace any workload you want to throw at us. And so it still is really flexible as a platform. And because of that, it attracts interesting problems, and ML is full of interesting problems. So because of that, we've got a ton of clients that come our way saying we need to run these weird ML workflows and workloads on Kubernetes, and we help them out.
And now, for people who are maybe tangentially familiar with Kubernetes, or maybe this is the first time that they've heard about it, although they must have been living under a rock for the past 5 years, how do you summarize it? What is your elevator pitch for somebody about what Kubernetes is and why they should care?
Yeah, that's a great question. So the simplest way that what it says on the tin for Kubernetes is that it's a system that will run your containerized workloads at scale in production. And if you don't know what a container is, you could just think of it as a little tiny machine, like a little micro VM, right? Very fast, very lightweight. If you've used Docker, you know what a container is. And if you've used Docker, you might think, well, I know what Docker Compose is. Like, I could just use that. Why would I not run all my stuff on Docker Compose and call it a day? Well, because there's a lot of extra stuff that has to be thought about when you're running that in production. Docker Compose is great for your laptop, but even though I know a couple of companies that have done this before, you should not just Docker Compose up on a server and walk away, right? You need something stronger for that. And that's what Kubernetes provides. But that's what it says on the tin. And that is like, that's the thing that you would use it for. But the reason that Kubernetes became so popular so quickly is because it embodied all of the Google SRE best practices, the site service reliability engineer best practices, right? And as part of that, it has this incredible API for automation. And that is the thing that makes Kubernetes so wonderful and so ubiquitous, is that it is this one API that if you as a software engineer learn that API, you no longer have to worry so much about learning the AWS API and the GCP API and the Azure API. And frankly, the Kubernetes API is extremely well built. I can say with confidence, I've never seen an API that is so well reasoned about and so well created. It's just really wonderful. So that's when we teach students about Kubernetes in like our core K8s class, that's the message that we hammer home a lot, is that sure, it's there to run your workloads and it does it using all these SRE best practices, but it's really the API that makes it shine. Unfortunately, though, Kubernetes is pretty complicated. I mean, like that workshop I just mentioned, it's 5 days long in like afternoons, but like tons and tons of content just to get you up to speed on Kubernetes. It's a very complex beast. It's about as complicated as learning Linux from scratch.
Which many people do just for fun.
Yes.
For the purpose of this conversation and this audience, Kubernetes, as it applies to the machine learning and AI ecosystem, what are the aspects of machine learning that you would like to discuss and how they pertain to Kubernetes as a environment, either for deployment or experimentation, and just Kubernetes as a target for machine learning?
Right. Great question. And again, not a machine learning engineer, talking kind of secondhand with regards to the type of work that we help our clients with, right? But like I said before, Kubernetes is extremely flexible, so it's kind of there to help with most aspects of ML workloads. Model tracking and versioning, exploration through Jupyter Notebooks. We've built systems where it runs a huge number of Jupyter Notebooks at scale with tons of data behind them. And that's really interesting because that's a thing that 12 factor would be really bad at, because Jupyter Notebooks are kind of semi-stateful, right? Like, you don't want a long running Jupyter Notebook computation to just be killed in the middle. Kubernetes is pretty good at that kind of stuff. Obviously, inference, you run the model in production and you serve the actual model, where you care about things like the efficient and multi-tenant use of GPUs. Then there's also training, where you've got efficient parallel scheduling across massive amounts of GPUs. All of these things can be done on top of Kubernetes.
In your experience of working with teams who do have machine learning workloads, they are using Kubernetes. Machine learning never exists in a vacuum. There are always many other support systems, both organizationally and technically, not least of which is data engineering for being able to feed data into those machine learning models for training and updating, but also operations for being able to monitor those models and identify when it needs to be retrained or tuned. What are the benefits of Kubernetes in that socio-technical ecosystem of machine learning, and some of the ways that you've seen that be leveraged to improve the efficacy of machine learning engineers who are trying to just get their job done?
That's a great question. I mean, I think it comes back to that ubiquity, right? Kubernetes provides that one single API that all these different teams are very comfortable working within. The operations team is used to running Kubernetes for their normal full stack workloads. And so it's very comfortable for them to be using Kubernetes to support the data engineers who are moving all this data around. And because Kubernetes is a lot more flexible than the old 12 factor models, it's much easier to construct a system through the Kubernetes Lego bricks, the different volume types and stuff, where you can efficiently move that data around. So all these support teams, and you're right, we see this in almost every company that we work with. It's not just an ML team off in a corner. You have to have many teams supporting them for them to be effective. They can all leverage a platform like Kubernetes to get their job done, and they're all speaking the same language that way.
The other interesting element of Kubernetes is that it has become, I guess, the ochre jelly, if you will, of the cloud ecosystem, where it just consumes everything that it touches and everything that comes in
Yes.
contact with it. And as a result, when people think Kubernetes and the inherent complexity that you already mentioned, that complexity balloons to encompass all of the things that Kubernetes has consumed in the process or that have become attached to it as a result. For one example, you mentioned that if you're using Kubernetes, you don't necessarily have to be as familiar with the AWS or the GCP APIs. And there's actually a project, I think Crossplane is the name, where that's its whole
Yep.
purpose, is that they actually just push those APIs underneath Kubernetes so that you use Kubernetes to manage those resources. And I'm wondering how emergent complexity of the Kubernetes ecosystem has maybe acted as a deterrent for people from approaching Kubernetes as a solution to their problem, because of the fact that they just view it as this amorphous mass of complexity that they don't know how to get started with.
Absolutely. Absolutely. I mean, people talk about the complexity of Kubernetes, and it is very complex. Like I said, it's on par with Linux and learning Bash and all that from scratch. But it's nothing compared to the complexity of the wider CNCF ecosystem. We've all seen, or if you haven't, go to just Google CNCF ecosystem, and you'll find this website you can go to that has all the logos of all the companies and open source technologies that are participating in and surrounding Kubernetes, right? And some of those fairly simple, Argo CD, things like that, not too hard to understand and used in almost every Kubernetes installation. Some things like Crossplane, incredibly complicated, almost as complicated as learning Kubernetes itself. Same thing with like Istio. Istio is incredibly complicated, and so you do need to be mindful and careful of how much you add on to Kubernetes, because you're taking on the load of maintenance and understanding and configuration and everything with every one of those components you use. You're spending your innovation points, right?
Now, for the purpose of actually using Kubernetes in an ML team or as an ML engineer, you mentioned the statefulness aspect when you were talking about Jupyter Notebooks. Machine learning is inherently a stateful operation, at least for the training portion, serving slightly less so. Because of that fact, what are the ways that machine learning workflows start to hit up against the edge cases of Kubernetes, and some of the ways that you have to customize your Kubernetes runtime to be able to account for the statefulness and also the extreme burstiness of the use cases around machine learning?
Right. I mean, Kubernetes had for the longest time a bad reputation around stateful workloads, right? It started as completely stateless. It was, run your full stack workloads on Kubernetes. And if you needed a database, well, that's what you go to Amazon for afterwards, right? Database should be outside of K8s. And it added this thing called the stateful set, which originally called the pet set back in 1.5. It has been a slowly maturing feature. Like things like volume snapshots are relatively new. But at this point, it's about polish with Kubernetes and stateful workloads. Many of our customers run databases, large amounts of data on Kubernetes, and it's just fine, right? It works well. Does it work better than running it on raw EC2? Probably not. In fact, definitely not. But you get that ubiquitous API, you get that consistent substrate for managing those databases, and that's worth it to a lot of our customers. And you're right, machine learning workloads have a lot of state associated with them, a lot of data associated with them, but they're not quite what I'd call stateful in the same way that a database is. Like I think of them as semi-stateful. And what I mean by that is if you lose your disk during the training phase of working with a model, like your company's not going to go bankrupt, right? Like when GitHub lost their primary database way back in the day, that was big news, right? Everybody who used GitHub knew that had happened, and it caused days of downtime while they recovered. It was really bad. And yeah, you'll lose, potentially hours or days of data if you lose your disk, but it's not the same as a database. That being said, ML workloads are very interesting. Training, for example, you're running thousands of these processes in a single batch job in parallel, but not HA, right? So when you're a full stack developer, you're thinking, oh, in parallel, that's great. That means like if I'm running 1,000 of these processes, one of them dies, like it's totally fine. That's not how it works with training, as a bunch of your audience probably already knows. One of those processes crashes, and that's it for the job back to the last checkpoint. So hopefully your training process is doing frequent checkpointing. And that's especially bad when coupled with the GPUs that are being pushed out of the factory so quickly nowadays. Like they're very flaky. So your processes will die frequently, and you won't know if it's because your Python code had a bug in it or because the GPU itself just, pooped the bed. That's some of the interesting stuff that is challenging on Kubernetes. And I can get more into that in a bit. But there are parts of Kubernetes that work really well with ML workloads. Again, it was designed to do everything. Some things can take more effort, but things like inference works very well. Where you do have challenges around distributing the data of that massive model, but Kubernetes has tons of solutions for that kind of challenge. You do end up with like these massive containers sometimes, or you got like volume management for those models, but that's okay. Kubernetes gives you these Lego blocks that are very flexible, so you can solve them that way. And like I said, that API is great for automation, which means things like dynamic RAG pipelines, where each one of your ML engineers who's making some change to the RAG pipeline gets their own preview environment for that RAG pipeline. That works swimmingly. Like that's fantastic on Kubernetes. It's kind of what it was designed for.
To that point of being able to spin up these cloned ecosystems or cloned environments of a process or of a workflow, that is something that is very necessary in the experimentation phase of machine learning, data science use cases. What are some of the ways that you're seeing teams address that environment cloning or quick setup, and in particular, the experiment tracking and checkpointing and retry management around that workflow to be able to accelerate the experimentation cycle of machine learning engineers before they get to the point of solidifying, saying, okay, this is exactly the model that I am building, this is how I am getting it into production, but earlier in that cycle to be able to use that flexibility of Kubernetes and the ease of being able to take copies of environments to be able to enable teams to work together for that experimentation.
Yeah, I mean, that's a great question. There are a bunch of different tools for that workflow management, but it's part of just the declarative nature of the Kubernetes API that enables that, right? You don't have to clone an existing RAG. You already have, you call it the template. You've already got the container image and the source code that goes into that and all that. So you just create another identical version because the Kubernetes API is that it's all about declarative resources, declarative workloads. Now, there's a bunch of higher order tools on top of Kubernetes. Kubeflow is the one that everybody points to. It's getting a little long in the tooth, but frankly, the problem with the Kubernetes ML ecosystem right now is that it just like the ML ecosystem in general, it's moving so fast and there are so many different solutions that it's really hard to pick a winner right now and to say like, oh, this is the successor to Kubeflow. Everybody should be using this. Every company that we work with is using a different tool, and some of them, massive enterprise companies, are using Kubeflow all over the place, very happy with it, but it really depends upon your team.
Kubernetes is something that a lot of operations engineers, cloud engineers have put in the hours and put in the time to figure out and become accustomed with. That's not necessarily the case for ML engineers because they have enough complexity that they're dealing with just trying to understand how deep learning works and these generative models. What are some of the foundational elements of Kubernetes knowledge that you think are necessary for them to be able to use it effectively to solve their problems, and some of the ways that you, either personally at SuperOrbital but also in the teams that you're working with, are seeing the educational elements of Kubernetes for these ML teams, and some of the ways that you're trying to frame it in a way that feels natural and doesn't become overwhelming and just another job?
That's a great question. I mean, I want to say the ideal answer, which is you'd need very little knowledge of Kubernetes to be effective in your role. I mean, the ideal state. In fact, the authors of Kubernetes have said on the record that they never expected the users of Kubernetes to be slinging YAML. Right? They never expected them to be building the Kubernetes resources by hand. Kubernetes was always intended to be a platform for building platforms. And so in this ideal state, you'd have this perfect platform that insulates the ML engineer from the Kubernetes primitives by using these simple abstractions. You wouldn't be thinking about containers or pods or services. It would just be like, here's my code, please run it and give me the answer back. You would need something that exposes metrics, logs, real-time telemetry. It would have to provide debugging tools like the works. And we've seen teams go down that path of trying to build that. You're ending up building better and more flexible version of Heroku, which means you need millions of dollars of funding to make that work. It never works, right? That platform, unfortunately, doesn't yet exist. We're always, fingers crossed, kind of hoping for that to come about in the marketplace, but it hasn't yet. And in some ways, it's unlikely to exist because each team is different in their needs and their workflows. And Kubernetes really appeals to those damn blue collar tweakers because everybody wants to like modify, like everyone wants to believe that they're special and their own workflow is special. And Kubernetes facilitates that, right? It's one of the downsides of Kubernetes from my point of view. It is a bunch of Lego bricks and you can construct whatever your heart desires in there. And because of that, there's no platform that's going to have that same level of flexibility. It's kind of the same story as Linux in the 90s. You remember everybody was trying to produce these admin panels on top of Linux. Like you'd install Red Hat, you get your Red Hat admin panel. And the idea was you could do all of your operations work in that nice little GUI interface. But no one ever successfully provided that abstraction. It was always the case that the devil was in the details and you always had to drop down to the terminal and edit files by hand and read all the man pages, because the truth was the abstraction that was already being presented by this myriad of utilities on top of Linux turned out to be the simplest thing that made sense if everybody needs to be able to modify it. So in the end, it was simpler for all the people in the 90s just to learn Linux. Like nowadays, it's kind of assumed that you are competent on the Unix shell. You're not given a Linux laptop as part of your new job and say like, sweet, where's the admin panel? You'd be fired again, right? So realistically, it's the same thing. We all need to learn Kubernetes. And I don't think that's a positive statement. It's a really negative statement, right? But it is the truth. Just like we all have to understand Bash and Linux. Now, that doesn't mean we have to understand all of it. We don't have to become kernel hackers. We don't have to like understand the ins and outs of systemd, for example, on Linux. And you don't have to understand every aspect of Kubernetes as well, but you do need to know more than just the the pod deployment service triad, right? You need to understand things like the pod lifecycle, how they start, stop, and fail, or exactly how and when traffic gets routed to a pod, or the different volume types that are provided. And there's a ton of them, and exactly how each of those works, what, read write many versus read write once, and all those types of phrases. And the container ecosystem, you need to understand like how containers work, and especially like the container image layering system and how layer caches work. That's very important for ML engineers. So I'd like to say that ML engineers do not need to learn the details of Kubernetes, but just like you had to pay that tax to learn Linux back in the day, you have to pay that tax again to learn Kubernetes now. The only silver lining is, just like Linux, it was like the last one. Like it was clear at the time, BSD, OpenBSD, FreeBSD, and like Windows and such were not where the market was going for engineering skills. So you were pretty confident, like, okay, I'm going to invest this time, I'm going to learn Linux, and it's going to serve me well for multiple decades. I truly believe that's the case with Kubernetes. The Kubernetes ecosystem is only growing massively. And so the positive side is you don't need to learn AWS and GCP and all these different APIs. You just learn the one, right?
Apropos of nothing, but as you were talking about the Docker layering and image caching, it brought to mind the parallel with deep learning networks and the transformer architectures of being able to replace the output layer with your customizations and take advantage of all of the pre-training that's been done. It's a very interesting parallel there. But
that's a good analogy. I like that. Yeah, parallel. I like that.
And to your point of Kubernetes being a platform for building platforms, for many years there have been conversations saying, oh, well, Kubernetes will fade into the background and you won't have to know about Kubernetes. You'll just be using the thing on top of it. And there have been some projects.
I believed that dream. I did.
There have been some projects in the ML and data engineering ecosystem that build on top of Kubernetes and aim to be that. Most notably that come to mind are Flight from the folks at Lyft, which is their orchestrator for data engineering and ML workflows. And an early entrant, one of the first ones to build on top of Kubernetes, was Pachyderm. I'm not sure what the state of that project is. I think they still exist in some fashion. But as you said, they are a facade on top of Kubernetes, but you're never going to be able to do absolutely everything without having to actually dig down into the next layer of Kubernetes itself.
Right. It's absolutely true. And when I talk to people about like Flight and the different ML tools, I'm not saying that one of them is not going to come out as like the thing that you use. I really hope that one of them will mature to the point that that's the case. But it's always on the spectrum of either too complicated, and so it's really hard to get going with your ML team adopting this tool, or not nearly mature enough so that you're constantly fighting bugs and having to keep up to date with the latest version in order to avoid all the myriad issues that you're hitting. But again, it's really about the investment in Kubernetes itself, because like I said, it's a ubiquitous API. I mean, CoreWeave, for example, you're familiar with CoreWeave, the GPU cloud, right? When you sign up for CoreWeave, you don't get a bespoke API that they created in order to compete with AWS and GCP. What do you get? You get a kubectl config, right? They give you direct access to Kubernetes, which was a genius move, by the way. And I think we're going to see more and more clouds adopting that model, just saying, look, Kubernetes is a fantastic API. We do not need to reinvent that. In fact, by just using that, our customers are already familiar with how to use our tool.
Another interesting aspect of those frameworks on top of Kubernetes is what level of coupling you see as being beneficial, where Flight and Pachyderm, for instance, are very tightly coupled to Kubernetes. You cannot run one without the other, whereas there are other frameworks that support Kubernetes as an operational substrate, but do not require it. And I'm wondering what you see as the appropriate balance for that tooling ecosystem.
That's a great question. And I think my answer is going to be, I mean, everybody's going to have a different answer, but I actually fall pretty firmly on one side of the spectrum. And what we're talking about is what we internally refer to as either a cloud native workload, where it's just maybe 12 factors just built for the cloud and you can run it anywhere, right? Versus a Kubernetes native workload where it's making use of every ounce of the platform. Now, the same question applied back in the days of raw cloud, AWS, for example. As a company, you could say, I'm going to just build like a a generally good distributed system based on Unix best practices, and it happens to run on AWS, which means I'm taking on a lot of the extra responsibilities of like I have to deploy RabbitMQ instead of making use of AWS's queuing system. I have to deploy my own databases instead of RDS. And that is a really good idea if you are concerned about supporting multiple clouds later on. Maybe you want to go on premise. You don't want to be beholden to AWS's ecosystem of stuff. But companies that got the most acceleration were the companies that went all in on one particular cloud. They said, we understand we're never going to be running on GCP. We're never going to run on premise. It's not part of our future business model. So we're just going to make the very most we can out of each cloud. We're going to go 100% in, full throttle. But they're locked in. The thing with Kubernetes, though, is that it is becoming ubiquitous. More and more companies are coming to us saying, we want to be able to provide our SaaS on premise, and we see Kubernetes as being the delivery model to do it. So it's actually inverted the equation where if you go all in on Kubernetes, you're actually making things easier for the vast majority of users out there, because Kubernetes is becoming more and more commonly the thing that people expect to have. Now you've just got a Helm chart. It's super easy to install, right? So my philosophy is that at this point, you should not be worried about. In fact, you might even want to avoid tools that are designed for general purpose computing and just happen to have Kubernetes as a bolt-on attachment, because the integration is not going to be nearly as good. It's going to feel after the fact.
Now, Kubernetes, as we've been saying, has these sharp edges. It has the edge cases that you're going to run into where the facade that you're putting on top isn't going to do all the pieces that you want it to. I'm wondering, what are some of those elements of Kubernetes and the way that it is designed, the way that it is used or deployed, that start to become a hindrance when you're in an ML workflow?
That's a really good question. So I'm going to say something that I think people will scoff at. And I say that like, I think a lot of people who use Kubernetes in anger on a daily basis are going to be like, this is BS. There's no way that's true. I don't think Kubernetes has a lot of sharp edges. And I'm going to say that because sharp edges are basically justified bugs, right? Probably a lot of Python listeners on this channel. So the whole Python default argument thing where the values are retained between executions of a function call, right? Come on, that's a bug. Everybody knows that's a bug. Like no other language does that. It shoots you in the foot every time. And yet the Python team, they have no intention of fixing that. They're like, no, that's how it's designed to work. Ruby, which I used to do a lot of Ruby programming, the differences between procs and blocks and lambdas, like that's crazy. Like it should have just been one thing. They justified it for the longest time, but it's basically a bug, right? That's a sharp edge. Kubernetes is actually really well engineered. So of course there are bugs in Kubernetes, but they're treated with respect. Every once in a while, there's a bug where the core team will say, we get you. Like that is definitely a bug. We don't know how to fix it and we're working on it. Like one that we teach in our workshops is traffic will still get routed to pods that are in the process of dying. It's like a well-known, well-documented, you could Google this and you'll get 12 articles that show you like what's going on and explain it very well. And that's a bug, right? But they're relatively few. What Kubernetes does have is a lot of constraints and complexity, so that ML engineers are going to be unused to. For example, a constraint would be the lack of raw access to the underlying node, right? An ML engineer, especially a data scientist, is going to expect to have the entire machine at their disposal. They're used to SCP and SSH, right? They copy their code in, they SSH in, they run it, and they just leave it running. In Kubernetes, they have a container. So a lot of that access that they need, like CPU, memory, and also access to GPUs, et cetera, all that needs to be configured. And so those constraints usually can be overcome, but in doing so, you're drastically increasing the amount of complexity that you have to deal with in order to get there. It is a lot more complex, especially in the beginning. The activation energy is a lot higher than spin up an EC2 instance, SSH in, and just run some random Python code.
In your experience of working in this ecosystem, working with teams who are using Kubernetes for ML workloads, what are some of the most interesting or unexpected or innovative ways that you have seen them tackle that problem?
Everything about ML workloads on Kubernetes, by the very nature of how nascent this whole industry is, every one of our solutions ends up being interesting and innovative and unusual in some way, right? no, we're not at we're not at the point of maturity in this industry where you can cookie cutter out a solution and say, here you go. Now you've got your ML team, you're good to go. Right? It's always a bespoke configuration that is very dependent upon the needs of the team. We have seen some like unexpected, challenging lessons. So I've said before multiple times now that Kubernetes is all about the API, right? The API is really gorgeous. It is worth, if you're an engineer, it's worth studying the Kubernetes API just so you can build better APIs in your day job. It is extremely consistent. It's very predictable because of that. Like once you get used to Kubernetes, you just guess what the API is going to be, and you're probably going to be right. It's mostly declarative. It could be better on that, but that's a different topic. But it's designed to be declarative. You say, this is the end state I want. Kubernetes will converge upon that end state. It's democratic, which is very interesting to me. It's one API that you talk to, and it's the same API that all of Kubernetes, all the internal components of Kubernetes also talk to. It's the same language. It's just about a matter of level of access. If you have enough access as a user, you can mimic all the different parts of Kubernetes yourself, right? You're talking to the same API. And most interesting, the API is expandable, it's extendable. You can do the equivalent of a SQL create table against the API. You can teach the API new tricks through these CRDs, right? So the API is really fantastic because it was built by API focused engineers. It came out of the culture of Google. But the thing is, like, that's like at best 10% of the engineering world, right? I mean, like realistically, maybe 1%. And the challenge that we've seen comes when the other 90 to 99% of the industry is forced to use Kubernetes. So there's sort of an irony there. We created the best system we could imagine for working through an API, and most of the world is baffled by it. And the best part of it, that API, goes completely unexploited by these teams. And data scientists in particular are a great example. We're like, here, data science team, we have bequeathed you with this phenomenal API-driven work-doing system. And the response is, by and large, that's great. I want SSH. Where's my SSH? Like, I'm very confused right now. Why don't I have SSH? And the value of that API, and it's not their fault. To be very clear, that complexity is a major fault of Kubernetes. And that's why these data science teams need other teams around them to produce all that automation and to leverage that API on behalf of the data science team. But yeah, that's the thing that was most surprising for me, because I came out of that world. I came out of the API driven world, and I'm like, oh, this is perfect. Everybody's going to love this. And it turns out maybe not so much, right?
It's the law of conservation of complexity, where you can never remove complexity. You can only hide it away in different blocks.
Right. Exactly.
We've been talking about using Kubernetes for running machine learning, but as you're talking about the fact that Kubernetes is this API-driven system, it has all of these declarative and eventually consistent capabilities, which has the idea of convergence in the same way that machine learning models will converge upon the optimal solution within that neural network environment, which also brought to mind the question of what are some of the ways that you're seeing machine learning being applied to Kubernetes for its operational capabilities?
Oh, that's a great question. I do have to be careful here because one of our clients is focused in that space. So how do you say this? There's ML ops and there's AI ops, right? I think is the way we've decided to kind of split this up. ML ops is operations for machine learning teams, and AI ops is the other way around, machine learning teams for Kubernetes, right? Or for operations. I think that is going to be a very important. I think that's going to be groundbreaking for the industry, for the Kubernetes industry in particular. I'm also extremely bullish on ML and AI and all this stuff in the future in general. But we just talked about all of that complexity, and how do we talked about the fact that you can't build a platform that provides the right abstractions on top of that complexity. It seems fairly natural to me that what we need is something like that solution, something where you're applying AI to that problem. Again, I need to be really careful about how far I go with that conversation, but yeah.
Yeah, it definitely seems as if it doesn't already exist, we are not very far off from this world of the analogous space in data engineering is text to SQL, where I say, this is what I want. The AI gives me a SQL query that I can run of in
Right.
Kubernetes saying, I want this to be running in this environment. And then it says, here's a bunch of YAML. And so for people who are in the process of deciding how they want to build and manage and deploy their ML workloads and organize their ML teams, what are the cases where Kubernetes is just absolutely the wrong choice?
Thank you for asking that, because I feel like I'm coming off as a bit of a Kubernetes fanboy, and there's an obvious bias. We built a company on Kubernetes, right? But at the same time, our value to our customers is being very transparent and clear about when Kubernetes is not the right solution. I was just talking to a non-ML team who needed just a regular platform for 12-factor-ish stuff. And I'm like, you should not be running Kubernetes. It's very complicated, right? And there is definitely some gaps with the ML space. So, like I mentioned before, ML workloads are very interesting, and training is a great example. You're running those thousands of processes in a batch job in parallel, but again, not HA. If one dies, it's very bad. And because of that, training is not ideal on Kubernetes, not only because of the complexity of the processes dying and the restarting and all that, but also just because of Kubernetes limitations with regards to its scheduler. The Kate scheduler is very simplistic. It's ironically, it's like the biggest chunk of code in Kubernetes, but because scheduling is such a difficult problem, it's not as sophisticated as it could be, especially for batch workloads. There is the concept of a job in Kubernetes. It's pretty crap. It's basically like run this pod once, fire and forget. It does have these fields of parallel and concurrent, but they're useless. Like nobody uses jobs in that way. There's tools like Kubeflow where you can get the concept of run this set of short-lived pods, like more than one at the same time, but it's still not a great experience. And by the way, that's called gang scheduling. I'm sure your viewers, your listeners already know. When you're running like a wide set of processes in this job, and they all have to start at the same time, and the whole job's not complete until they all complete. Gang scheduling, right? Now, that's tricky, but doable on Kubernetes. The experience is not great. What I find interesting is there's a fundamental limitation in Kubernetes that it does not know how long a job is supposed to take, right? You submit a short-lived pod, it runs until completion, either good or bad. Failure or success, and then it's done. But you don't tell Kubernetes, by the way, this job should take 4 hours. And because of that, it can't do some really interesting things. Like imagine you had this massive parallel training job, 1,000 pods for 1,000 nodes. Each pod takes up basically the entire node, like a huge parallel job. I say huge. That job may never run in Kubernetes, even though you've got 1,000 nodes, because smaller jobs will keep getting scheduled on those nodes. Like the Kubernetes scheduler or Kubeflow, for example, might say like, okay, I can't run these yet. I'm going to wait till all thousand of the nodes are completely empty. That state's never going to happen, because in the meantime, the normal Kate scheduler is going to be sending regular jobs in, and Kubeflow is going to be sending regular jobs in. The smaller jobs are going to starve the larger job. But older schedulers like Slurm, for example. Have you heard of Slurm? You've probably used it, right?
Yes,
In
I'm
the
familiar with it.
HPC. Yeah. Slurm's terrible, right? It sucks in many ways. It's basically a hodgepodge of shell script and terrible C code, right? But it understands the needs of batch jobs in a way that Kubernetes does not. So fundamentally, it's also, by the way, much simpler to use. For those who've never used Slurm, it looks like you're just writing a shell script and you send that into Slurm through SBatch, I think it is. And that's it. Kubernetes is much more complicated to use. You have to create a container image and all these things and YAMLify it. But fundamentally, Slurm knows how long jobs should take. And because of that, it can do these really smart scheduling gymnastics across time. So it can say, well, this job needs all 1,000 of the nodes. I can see that all of the nodes are currently scheduled to be free, available in exactly 12 hours. In the meantime, somebody else sends another small job that has marked on it, this is only a 4-hour job. Slurm says, I can totally schedule that. All the nodes will still be available in 12 hours. That's called backfill scheduling. And that is something that you can't even graft onto Kubernetes right now. It is a fundamental limitation of the platform. And because of that, many ML teams have said, we're going to use Kubernetes for inference, for exploration, for all these different aspects of, for managing the model states and all that kind of stuff. But when it comes down to actual training, we're just going to use a bare cluster of EC2 or actually spin up a Slurm cluster or something like that. We're going to go a little bit lower level and not try and lean on Kubernetes for the real training.
At the risk of getting too far down another rabbit hole, I'm wondering what you have seen in the broader ecosystem of being able to maybe work at the layer just above the Kubernetes scheduler to take advantage of its flexibility, thinking in particular in terms of things like Ray or Dask or I know there's a project called Horovod that is designed for parallel training of large machine learning jobs, things like that.
I mean, like I said before, there's a ton of those types of tools, but at the end of the day, some of this is a fundamental limitation in Kubernetes. No tool on top of it can stop the traditional Kubernetes scheduler from throwing the wrong process onto the nodes at the wrong time so that you can no longer set aside all of that space. I think this is really interesting because until now, the Kubernetes core team has kind of, I don't want to say rested on their laurels. They're all doing really hard work, but project has moved into a polish and fit phase, right? Where the major features are pretty much done and the core team has been focused on fixing all those bugs, looking for rough edges, improving things like stateful workload management, but none of it's been like fundamental changes to Kubernetes. And I think that the ML industry is starting to push the boundaries of what the core team ever expected workloads to look like. And because of that is going to be putting pressure on the core team to go back to the drawing board for some of these larger features. It's going to force Kubernetes to evolve when Kubernetes had moved out of an evolution phase.
And as somebody who is working very closely in the Kubernetes space, and as you're working with clients who are very interested in and invested in this ecosystem of machine learning, what are the elements of the Kubernetes project and ecosystem that you're keeping an eye on to help improve the story for people who are trying to use Kubernetes for machine learning?
Yeah, that's a great question. Beyond what we were just talking about with like the scheduler and the evolution there, I think there are some other areas where Kubernetes needs to improve, and we're keeping an eye on what those improvements look like. Most of them can be handled by tools on top of Kubernetes, but areas like networking speed, good use of InfiniBand and things like that's something where Kubernetes, you can do it. It's really complex and hard. Another one is access, like deeper access to the actual hardware. For example, being able to align a CPU core with a GPU core and the memory bus in between and all of that, like really lining it up to eke out the most performance that you can get is something that's, I think, impossible. One of my engineers swears that he knows how to get that done, but I think that's impossible in Kubernetes right now. The different volume types, I think that's going to explode a lot more because of efficient distribution of container images is another area where there are tools for this, but I think that they're going to have to improve, and I think we're going to see some evolution there as well.
Are there any other aspects of Kubernetes, machine learning, the confluence of the two that we didn't discuss yet that you'd like to cover before we close out the show?
I think this has been a fantastic conversation. I feel like we've done a great job of exploring the different corners of the space.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for machine learning today.
That's a great question. Again, I'm not an ML engineer, but from what I've seen, that problem of the massively parallel jobs that are not HA. So any one process that dies basically pushes the entire job back to the last checkpointing. Hopefully your jobs are doing really good regular checkpointing. Your whole job goes back to that last state, and you don't know if that death was due to. I mean, you have to do a lot of investigation to figure out if that death was due to a hardware failure or to your own code. I think that there's a lot of room in the observability space for these massively parallel jobs, the observability and even remediation space. And I think it'll be really interesting to see how ML itself is shined back on itself and used to solve that same problem, because that does feel like a problem that would be really well geared towards an AI solution.
Well, thank you very much for taking the time today to join me and share your experience and expertise in the Kubernetes ecosystem and the ways that you're seeing machine learning be run on that substrate. So appreciate all the time and energy that you and your team are putting into helping folks on that journey. And I hope you enjoy the rest of your day.
This has been a lot of fun. I really appreciate the conversation, and hope you have a great rest of your day as well.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.